Hey guys, today we're going to take a look at question 9, which is find the trajectory of the missile. So the missile start from this point, and the person start from this point, which here is given. It's the initial condition. Okay, let's find it. The trajectory. So if we draw the graph here and set like a point on the trajectory to be x and y, and the speed is v rocket, and it is pointing to the person, so it must be on this line, which is vp, and the distance traveled over here is vp dt. And because the velocity of the rocket is constant, so we know that if we take a small portion on the trajectory of the ds, which is our arc length, we know that the formula for the arc length is dx squared plus dy squared, which is equal to 1 plus dy dx squared times dx. So because the velocity is constant, so Vr is equal to 1 plus dy dx squared dx and dt, which is ds dt, you know. So the first equation we have over here is this. And the second equation we have is that this is a tangent line of the trajectory. So we get that the second is dy dx is equal to tangent. And from geometry, we can see that this distance is vp t. What is going on here? This one's t. And minus y, so this distance, and this over here is equal to, because this is given, this one is L minus x. So basically this third equation is vpt minus y divided by L minus x is equal to tangent, which is equal to dy dx. So now from the third equation, if we move this to that side, we have vpt minus y is equal to L minus x dy dx. And we see over here, so we want to get something about dt dx or dx dt. So if we take the this stuff, so basically take the d dx both sides, we can get dp dt dx minus dy dx, and using the chain rule over here is minus dy dx and plus L minus x dy dx, and this term cancels each other out, so we got dt dx is equal to L minus x divided by v person dy dx squared, or second derivative. So now if we plug in to 1, which is, let me copy it. So from this equation, if we take the reverse, we can dx dt, or no, we don't. So if we take this to that side, so we can Vr times L minus x Vp dy dx squared, and this one is equal to 1 plus y dx squared. So now if we set, okay, let me see, and you can see over here, if we set u is equal to dy dx, so this is basically du dx, and this term can be simplified VRVP times L minus X du dx, and this is equal to this. Okay, let me check real quick. And if we move this to that side, and we can set gamma is equal to Vp over Vr, we get L minus X is equal to du dx, and this is equal to gamma 1 plus u squared. And if we move this to that side and dx term to that side, and this to that side, we can get the equation to be du 1 plus u squared is equal to gamma and times dx over L minus X, and takes the integral. And from the initial condition, we know the slope at start is equal to 0 because it is aiming to that point. So basically, we integrate from 0 to u, and this one is 0 to L. Oh, or no, 0 to X, yeah. And for this term, we can see that 1 plus sinh, and if we choose a variable like eta squared is equal to cosine cos squared eta. So using u substitution, we have this is equal to eta, and du is equal to cos eta d eta. So now we can plug in, and we can get 1 plus sinh squared, and this term is basically cos. And the above term is also cos. And d eta. And from blah 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 to blah blah blah. And we can cancel the terms out. And it leaves the term to be like eta. And from blah 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 to blah blah blah. If we substitute back, and from this we can see that eta is equal to the inverse of sinh of u. So from the equation, we know that like sinh x is equal to ex minus e this, and divided by 2. And to find the inverse, we can say that u is equal to e eta minus e divided by 2. And so now we have like 2u and times and e squared and minus 1. So basically, this is a quadratic equation, and we can treat it as x, and this one x squared. So now we have that e2 u minus 2u e u minus 1 is equal to 0. So 2u plus minus 4u squared plus 4 divided by 2 is equal to e u. Because this term is always greater than 0, so we can't have the negative because this term is greater than this term. So now we only keep the plus sign over here. And we have that u is equal to ln of u plus u squared plus 1. Okay, now, and for this term, we can use u substitution for u is, or no, use this function is equal to L minus X, so d this is equal to dx. And now we have this is equal to gamma dx L minus X, and this term is going to be equal to d, which is from blah 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 blah, and we have this is going to be L minus x, and then from 0 to x. And now we have ln L minus x and plus, because there's a negative sign, so negative is positive, ln L, which is equal to ln L minus x. And because we know that there's a property, which is this, is equal to L x gamma. So now we have the equation to be ln L minus x to the power of gamma is going to be ln u plus u squared plus 1. And we know that this term is going to be equal to this term. So L minus x to the gamma is equal to u plus u squared plus 1. And if we move it to that side and take the squared, so we have L minus x gamma minus u squared plus 1 is equal to u, and take, oh my god, no. U takes the square plus 1. This is going to be L minus x 2 gamma, and this one is minus 2 L minus x gamma, and there's a u, and plus u squared is equal to u squared plus 1. So basically this cancels out and leaves the u to be L minus x 2 gamma and minus 1 divided by this term, and is 2 L minus x gamma, and this is going to be u, which if we simplify we can get this is going to be 1/2, u is equal to 1/2 of L minus x to the gamma, and this one is minus L minus x to the negative gamma. And this we know from here. Wait. And from here, we know that this is going to be equal to dy dx. So if we take and move this to that side, we can get dy and take 0 to y and 0 to x of 1/2 of L minus x gamma minus L minus x negative gamma, and this one dx. And if we integrate, we can get y is going to be L2, and wait, let me see. Yeah. Wait a second. And this one is going to be L minus 2, 1 plus this, 1 minus 1 plus, and y minus 1, and this. Okay, here. So this is the trajectory of the function where gamma is equal to, let me see, and gamma is v person divided by v rocket. And now if we want to find the time it takes to reach when the rocket explodes, so we have that this one is going to be y is going to be like this one is L, yeah, and YL is going to be, if we simplify, we can get this is going to be 1 gamma divided by this L, and T is going to be Y star divided by the speed of the rocket, which is going to be 1 minus gamma, and v person. This is a pretty cool problem, and we'll go over the rest in the next video. Okay, bye.